Hey guys, Mr. Covey here. Sorry I'm not at school today. It was unexpected because my baby got sick, so I had to stay home with him. Yeah, sorry. Hopefully I'll be back Monday. That's the plan. Just a couple of reminders. You guys got your test next Friday, but next Wednesday you're going to do a single FRQ, free response question. It's going to count as part of your test. Monday and Tuesday next week, straight review. Nothing new. I have a small new thing to teach you today that will be easy. At least I hope it'll be. Cool. And it's an area estimation thing. Cool. It's called trapezoid rule. It's finding the area under the curve using trapezoids. It's not that hard. You guys will think it's easy. I do have one word of wisdom for you. Never have a baby, because then the baby's going to get sick and you're not going to be able to come to calculus class. It's sad. I know. All right, cool. So I think the easiest way to do this is, first you got some book problems that's for over the weekend. Don't forget that, oh yeah, the graded homework is due on Monday too. So on Monday I'll have you guys turn in that graded homework too. Okay. If you have questions about it, you can email me over the weekend and I'll email you back too. Or you can email me right now. Cool. Okay. So I think the easiest thing for you to do is to pause this right now. I'll throw underneath this video, there's a little like 8-minute Khan Academy video where he does an example of this real quick. So pause this, go watch that 8-minute Khan Academy video, come back here, and then I'll pick up and pretend that you watched that. So I'm gonna assume you watched it. Okay, pause this video, watch 8-minute Khan Academy video, come back. Okay. I hope that's not that bad. It's, oh, instead of using rectangles, use trapezoids. Okay. Just one thing I want you to know. First, the trapezoids are sideways, obviously. Yeah. So I hope you noticed that from that video. Second, if you're like, wait a second, can there like be a little bit of a quicker way to do this since we're like kind of like it's all set up with the delta x's and stuff? There is a shorter formula, and I'll show you that formula real quick right now. But then I'll tell you to not really worry about it. If you look at the calculation you're doing, so like if you look at this picture, and here are our trapezoids. Okay, they're sideways trapezoids. These are the two parallel sides. Those are our two bases. Yeah. You do a calculation like they did in the video that looks like this. Okay. What you'll notice is that like each of those area calculations has a delta x and a 1/2. And that like everything's repeating twice except for the two end values, right? So like the very first, like this is the bottom of one trapezoid and the top of another, and this is the bottom of one trapezoid and the top of another, the bottom base and the top base, except for the two end ones, except for this one and this one. Okay. And so you can get a little formula, and the formula just looks like this. Okay. What it says is figure out the height, the width of your interval, which is the height of your trapezoid, and then figure out all the y values. And you don't have to divide the y values by 2 because you use them twice. So although the area of a trapezoid formula has a 1/2, because you have all of them used as a base twice, the 1/2 disappears, except for the end y values because they're only used once. Okay. Cool. If you used infinitely many trapezoids, you'd get the exact area too. Why didn't we start out with trapezoids? We didn't start out with trapezoids because they're more complicated. So infinitely many rectangles will give you exact area, and so will infinitely many trapezoids. But since rectangles are easier to use, we used rectangles. Okay? But, like you see, trapezoids as a general strategy do give a better estimate than rectangles. Okay. Can we go back and say one more thing? Oh, sorry, actually, I don't want to confuse you. I'll say one thing and I'll go back. This formula is sweet. Oh, cool, there's an easy formula. You're not really going to use it that much. Because the thing that's nice about the formula is it works if your interval is divided up into even chunks. And you're like, well, I'll just always divide it into even chunks. But the AT exam usually doesn't let you do that. And the way that they don't let you do that is they don't give you the function. Okay? They'll make it so that the delta x, or the height of the trapezoids, is not consistent. So some trapezoids will be taller and some will be shorter. And the way that, I'll show you what they do in a second. Yeah, I'll show it to you in like 2 examples here. But I wanted to go back and say something I forgot to say. If you're wondering, why are we still doing area estimates? We know how to find exact area under the curve. It's because our exact area under the curve strategy, our way we evaluate definite integrals, relies on you knowing the function and being able to find the antiderivative. So if I give you a situation as simple as, and I gave you this the other day, hey, find the area under this function from 0 to pi halves. You can't do this. Why? Because you can't find the antiderivative of this. So if you really wanted to estimate the area underneath that curve, or you wanted to calculate it, you'd have to estimate it. How would you estimate it? Well, you can use rectangles, or I just showed you can use these trapezoid things. Cool. I want to go through a few questions with you related to this. First, pause, give this problem a try, and we'll talk about it. This is calculator active. Okay. So I kind of just gave you an example of this before, but so if I ask you to evaluate this definite integral, you can't find the antiderivative. Why not? Because u sub doesn't work. So if you tried to make this the u, you wouldn't be able to introduce the du, so u sub wouldn't work for this integral. So if you were asked to evaluate this, they might point you in the direction of using trapezoids. And in this case, they asked you to use 5 trapezoids. In this case, our formula totally works nicely. Why? Because we're allowed to use even intervals. We're allowed to space them out 0.2 apart. Okay, so I got this. I plug in 0.2, 0.4, 0.6, 0.8. This was from plugging in 0. This was from plugging in 1. The 2 end values I divided by 2. Again, because they're not a lower base and an upper base. So they're the 2 that don't get double counted. Okay? So then in my calculator, here's my estimate for the area under the curve. Okay? Pretty straightforward. Go ahead and give this one a try. Cool. Very similar process. Check, again, something you can't find the antiderivative of, so using trapezoids makes sense. This half is because each one is half tall, has a height of a half. End values divided by 2, the rest of them are regular. Cool. Remember that if you do an estimate like this, it should be relatively close to the actual value, and you could get the exact value of this on your calculator, right, by using fn_int, by typing the definite integral into your calculator. So whatever we get out as our estimate should be relatively close, depending on how good our estimate is. In other words, like how many trapezoids we use or whatever. Cool. This is what the AP usually asks. Okay, so let's slow down here for a second. The function is continuous on this closed interval and has values that are given in this table. Use these intervals. It's kind of nice they even told us the intervals. What is the trapezoidal approximation of the area under this curve? Okay. So this is a little bit. The AP likes to ask a question like this for a couple of reasons. First, they don't tell you the function. So like, there's no option of typing the definite integral in your calculator or something like that, or finding the antiderivative by hand. They don't even tell you what the function is. All you know about it is this table. Okay, so you really are estimating the area under the curve, because you don't even know what the function is. The other thing that's interesting about it is that the x values they give you aren't evenly spaced. So if you drew this out and tried to draw some trapezoids, you'd have like, not very drawn very good. Come on, Mr. You'd have like a skinny trapezoid. That doesn't even look like a trapezoid. You'd have a skinny trapezoid and a fat trapezoid. And then you'd have another skinny trapezoid or a medium trapezoid. And then your other one might be super skinny trapezoid. So your curve might be whatever. And you're estimating with different size trapezoids. And all this does is it disallows you from using the formula. Okay, so there is no formula here. How do you do it? Well, you just do it kind of how the guy did it in the video. You just like do it manually by hand. So you look at thinking about drawing a trapezoid with this chunk. Well, its height would be 3. I'll draw a picture. Its height would be 3. The one side would be, the one base would be 10. The one base would be 30. That's the trapezoid we're talking about. How do you find the area of that? B1 plus B2 is 40. 1/2 of 40 is 20. 20 times 3 is 60. Boom. PSGH. Next one here. Height is 2. 2 bases added together is 70. 70 divided by 2 is 35. 2 times 35. 70. +40 plus 20 is 60 divided by 2 is 30. Height of 1, 30. Add it all together, boom. You don't need a calculator for that. Nice try, Mrs. Lemke. Cool, you with me? So the way that they'll get around you being able to evaluate on your calculator or actually just do the antiderivative, like why would you need to estimate it? Well, what happens if you just had a table? Okay, that's the basic idea. Again, why didn't we introduce this earlier on? Because we built everything with rectangles because rectangles were easier. So this trapezoids idea is kind of an add-on rule. If you want a little piece of extra information, sure. You want a little, okay, you want a little extra math? All right, extra math time. There is something where I had to go look something up to make sure I didn't explain it wrong because we haven't taught it in a long time. It's not on the AP exam, so it's extra information. But if you're like, what would be better than trapezoids? Well, what happens if you could make the top curved and make it a little parabola? And there is a way to do that. It's called Simpson's rule, after the TV show. No, not after the TV show. And basically, instead of making like rectangles or little trapezoids, you're allowed to make the top into little parabolas, and it makes them even better. Okay, but we don't learn that. But anyway, there's extra information. So if you're thinking like, oh, I bet you could do an even better approximation, you can. Okay, so then the last thing I want to do is there's this actual real free response question in your packet that I'd like you to give a try to. So I'd like you to actually pause, give it 15 minutes, unpause, and I'll go through the answer key with you. It is calculator active. There's a real AP question from 2011. What were you doing in 2011? I was turning 21, 21st birthday. I was a junior in college. I want you to pause, give this a try, calculator active, unpause. We'll chat about the questions. Make sure you use your calculator a lot. This is definitely like heavily calculator active. Okay, so this is a table, check. And the table has time and heat of something that's cooling down over time. It's this pot that's, at some temperature at the beginning and it's cooling down over time. Make sure you read the stem closely. They a lot of times say like stuff that changes everything, so read it real closely. It's like 2 sentences. Read it closely. First thing they're asking you to do is approximate the rate at which the temperature is changing at time t equals 3.5. Estimating the slope at 3.5, how are you going to do that? Well, you use 2 and 5. Okay, you're just estimating the derivative at 3.5 using the two x values that are closest to 3.5, the two t values. Yep. It does ask you for units, I believe, or show computations. Check, you should put some units in there too. So since we're measuring the temperature in Celsius, the rate of change would be degrees Celsius per minute. For B is a little tricky, but it's the one that brought in the trapezoid. So it said, using correct units, explain the meaning of this guy in the context of the problem. I hope you looked at this and go, oh, that's the average value of the function. What's it the average value of? It's the average value of the heat, so it's the average temperature of the teapot over the 10 minutes. Okay, so that's the interpretation. It's the average temperature of the tea over the 10 minutes. How do you actually calculate that? Well, you're using the trapezoids to calculate this part, and then you're multiplying it by 1/10. Okay, how do you do the trapezoids? Well, it's like that table one we just did. You guys can bust out that calculation. Here is it. You know, here they just kind of brute forced it out here. Okay, and then they multiplied it by 1/10. I'm going to tell you right now the most common error is to forget to do the 1/10 after you do the trapezoids. Remember that you're saying the average temperature. So at the end of the day, you look at this, you're like, what's the average temperature? I don't know, like 50? You know, I mean, it should make sense. Don't say 500 is the average temperature. It went from 66 to 43. So make sure your answer makes sense in the context of the problem. Okay. Moving on to C. This is a classic, looks hard, very easy question. The integral of the derivative of h, wait. How do you evaluate the integral? Definite integral of something? We do the antiderivative. What's the antiderivative of h prime? Just h. This is just h of 10 minus h of 0. Just negative 23. Okay. What does it mean in the context of the problem? It's the net change in temperature. The temperature of the tea drops 23 degrees. Okay. Jumping back here, I haven't mentioned the points thing. Just so you know, for stuff like A, where it's just an answer, it's an answer. You either got it right or you got it wrong. If you put negative 2.668, you get no points. Here, the estimate is correct or not. You wrote 52.95, or you didn't. You could have wrote 52.950, but if you wrote anything else, you don't get that point. A point for having it look like a trapezoidal sum, and a point for the explanation using the right units. Okay. So if you didn't say the average temperature of the tea over 10 minutes, you didn't get that. If you just said the average temperature, I don't think they would give you that. They grade these really hard, remember I said that. Okay, so back here, you'd have to have the value of the integral, so you'd have to actually have done that and gotten negative 23, and then said something about it being the change in temperature from time t equals 0 to 10. Cool. Last question here, classic one they ask all the time. Sorry, I had to read it real quick. They're introducing a completely different function, okay, and ask you to do a completely different thing, and then compare it to the t, okay? The thing they're asking you to do here is that poetic version. So they give you an initial temperature, this is what we talked about on Wednesday. They give you an initial temperature, and they give you the rate, and they ask you the temperature at a later time. Well, you integrate the rate, so that it's no longer a rate. When you integrate a rate, it ain't no more a rate. It looks like this. You take the starting amount and you integrate the rate to figure out the net change in biscuit temperature from time 0 to 10, and figure out that at the end the biscuit is this hot, and then just answer the silly question they ask, which is like, how much hotter is the tea than the biscuit? Well, it's subtract them and figure it out. Okay? Anytime they give you a starting amount, a rate, and they ask for an ending amount, that's fundamental theorem. You integrate the rate to figure out the net change between the bounds. Cool. And I think this is a really kind of standard FRQ relating to this stuff. Cool. So I hope you found some success with that. If not, it was good practice. Thank you guys for bearing with me being absent. If you still have time left in class, work on book problems, any of the USEP stuff you have left over, or any of those new book problems I'd like you to do also. Some of it's just review. Cool. Monday, Tuesday, review for your test. We got lots of good stuff. I'll be there to answer all your questions. Grade homework due Monday. Email me if you got questions about that. All right. Thanks for listening, guys.